Let me introduce another new concept called as acceleration. Before we start with talking about acceleration, we need to recall when does velocity change? To answer this question, we need to talk about what is there in a velocity. There are two components in a velocity. One is direction and another is rate of motion. So to answer the question of when does the velocity change? Well, there are three possibilities. One is when the direction changes but not the rate of motion. The direction may not change but the rate of motion changes, and if not, both of them change. In all of these three cases, we can tell that the velocity has changed. So a decent example over here is non-stop train. Over here it is say 100-meter run, and over here it is any random motion. So this thing I just want to recall, this thing is nothing but delta. It's read as delta, which means change in. Okay, now let's define acceleration. Acceleration is a measure of the change in velocity of an object per unit time. Okay, let me explain the formula first, then you guys will get to understand what does it mean. So acceleration is to do with change in velocity, but yes, the factor of time also has to be taken into account because we have different amount of acceleration. There is a small acceleration, there is big acceleration, so amount of acceleration can change. So we measure with respect to time. So acceleration is a measure of change in velocity of an object per unit time. In simple words, you know that something is accelerating if its velocity is changing. Okay, something is accelerating if its velocity is changing. Symbolically, you can represent acceleration as delta v by delta t, which I already written over here. So let me expand over here. This is change of velocity by change in time. Right, so I hope you guys understood. Basically, all of this is a scenario wherein we have acceleration. Okay, basically acceleration over here is not equal to 0. Now let's derive the SI unit. Yes, we can derive SI units. The acceleration is change in velocity by change in time. If I express the ratio in terms of their respective SI unit, what is that we get? We get meter per second getting divided by second, right? Because velocity is meter per second and this is second. And we have meter per second into 1 by second, and so this is equal to meter by second square. Second into second is second square. This is the SI unit of acceleration. And to end with, let's recall everything. An object whose speed changes, it can increase if not decrease, remember, or its direction change, or both, it is said to have accelerated. Such a motion is called as accelerated motion. Like how we have uniform motion, in the same way we can call such motions wherein we have change in velocity as accelerated motion. See, if you think about it, it's not a new concept. It's a name we are just giving a name to something that we already know. What is that we already know? That velocity can change. Right? It's a very simple concept. We started with distance, displacement, speed, velocity. Any change in distance or displacement leads to velocity and speed, right? Distance, any change leads to speed. Any change over here, or let me put it as velocity, any change over here leads to acceleration. That's all. We're not looking into anything fancy. It's quite simple. It's an extension of each of it. And all of this is with respect to time, right? Time is a factor with respect to change in time. I hope you guys were able to link all of this. It's very simple. I think I made it very clear. So in all of this cases, the object is said to have accelerated, right? So please make a note of all of it.